These are the corrections to the Kognity 1.2 assignment. So question number 1, a train travels 64.7 plus or minus 0.5 meters in 8.65 seconds, plus or minus 0.05. What is the absolute uncertainty in its speed? Leave your answer to one significant figure. Step 1. Remember the rule. Step 2. Work out the answer first. Step 3. Deal with the uncertainties. In this case, the rule would be relevant to a division. We have a train travelling a certain amount of meters in a certain amount of time. So we're dealing with velocity equals distance over time. So what is the rule? The rule when we're doing a division is that you must add the fractional or the percentage uncertainties. Okay, so you're going to use this relationship, delta D over D plus delta T over T. So that's your rule. Step 2, actually work out the answer. So put aside the percentage uncertainties for 1 minute and actually just deal with the real data, which is a distance of 64.7 and a time of 8.65. You'll get a value of 7.48 meters per second. Once you have your answer, you can work out your uncertainty. Will be worked out using this relationship. Oops. And now if we substitute some values in, our fractional uncertainty in the actual value, delta V over 7.48, would be equal to 0.5 over 64.7 and 0.05 over 8.65, okay, which correlates to this relationship. Your answer rounded up to one significant figure without units would be 0.1. And be very, very careful when it asks for that specific kind of information. Question 2. The length of a pencil is measured using part of a meter rule that is graduated in millimeters as shown below. What is the length of the pencil? Well, the total length of this pencil has to be worked out using a calculation. And that calculation is because you need to do a subtraction. Okay? If that is where the pencil ends, and this is where it starts, you've got two values. I'm going to zoom in to try and work out those values. Now this is really big. You can see that the values would be 22. So here are our two values. You get approximately 22.1, and on this end you get approximately 16.1. So what do we have to do? We have to first think about our rule, do our calculation, and then work out our uncertainties. So what is the rule here? We're going to do a subtraction. We're going to subtract this distance, or actually we're going to subtract this distance from this distance. So the rule for subtraction is that you plus or you add your absolute uncertainties. You must add them. The second thing that you must do is the actual calculation. Forget about uncertainties for a minute. So now 22.1 minus 16.1 gives you 6. So now let's deal with our uncertainties. We've got our answer. If we add the absolute uncertainty, well, the absolute uncertainty here, because it's a millimeter ruler, it's an analog situation, and it's 0.05. But our uncertainty here is also 0.05. So we add our uncertainties, and we end up with an answer of 6 plus or minus 0.1. By averaging 3 measurements of the same quantity, which of the following can be reduced? Basically, there are two types of errors, systematic and random. A systematic error will occur by the same amount every time you take the reading. So even if you do it doesn't matter how many times you take that reading, it's always going to show up in your average. A random error, if it happens once, by taking more and more readings and averaging, you will reduce the actual value of that error. For example, let's say you are measuring the period of a pendulum swing and you do it twice. You get 1.6 and you get 1.2. Your average value would be equal to 1.4. But if this is a random error, the actual effect of 1.6 on your final answer is quite heavy. Let's see what happens if you take that reading again. Let's say you do it 5 times and you get 1.6, 1.2, 1.2, 1.2, 1.2. By working out the average now, you can see that the effect of 1.6 is going to be much lower. Your actual answer would be 1.28. Now, assuming that the real value...
I'm having trouble hearing you.
Sorry, Siri just went mental there. So if 1.28 is your final answer, then you can see it's way closer to the true, assuming that 1.2 is the true answer. Okay? So I hope that makes a bit more sense. The more repeats you have, the less effect a random error is. And in fact, the IB stipulates that for investigations, it's looking for 5 repeats. A student measures a distance 4 times. The readings are 37.8, 37.9, 38.1 and 38.2. What is the best estimate of this measurement? The first thing to do, again, is to try and remember the rule. You have to work out an uncertainty. So what rule are we using? Secondly, actually work out your answer, ignoring all references to uncertainties. And then number 3, work out your uncertainty then. So the first thing is to remember your rule. What are we doing here? We're dealing with averaging. We have a number of different readings and we need to work out the average. So what we're looking at is the spread, the range of results that we're getting, and we're going to divide that by 2. We'll do that in a minute, but you need to get your head in the right place. Secondly, we're going to work out our answer. So work out the average here of 37.8, 37.9, 38.1 and 38.2. And the answer should be 38.0 using the correct number of significant figures. Now let's work out our uncertainty. Take your largest possible reading of the 4 and subtract the smallest possible reading from it. So here we have 37.8 and 38.2. Once you have the difference, which is 0.4, divided by 2 to give you your range, which is 0.2. So your final answer is 38 plus or minus 0.2. These questions make you work hard for your money, and the nice thing is the answers are very close to the top. I'll show you what I mean in a second. A student measures 2 lengths as follows. A equals 10 plus or minus 0.1 and B is 20 plus or minus 0.1. Which of the following quantities has the largest percentage uncertainty? So you're going to have to work out the percentage uncertainties of all 4 and then just say which is the largest. So let's start. B minus A. Let's think about our rule. The rule is we're subtracting. So we're just going to add the absolute uncertainties. A on its own, easy. B on its own, easy. And A plus B is the same. All you have to do is add the add the absolute uncertainties. So those are our rules. The next thing we're going to do is work out the actual values. So forget the uncertainties. Okay, so here are our actual answers. B minus A gives you 10, A is 10, B is 20, and A plus B is 30. Alright, so just look back and check that that makes sense to you. Now part 3. Let's work out our uncertainties for each. Well, for b minus a, we are adding the absolute uncertainties, so it's 0.2. For a, the absolute uncertainty is 0.1. For b, the absolute uncertainty is 0.1. And for a plus b, the absolute uncertainty is 0.2. So those are our final uncertainties. But the question is about the largest percentage uncertainty. So now all you have to do is just work out these values divided by these values times 100. So I'll do those now. Okay, by dividing these values by these values and multiplying by 100, you get 2% for the first one, 1%, 1% and 0.6 respectively for the rest. This goes to show that the first situation, b minus a, gives you the greatest percentage uncertainty. Here's a similar exercise. The time for two events, A and B, are measured to be 5.1 plus or minus 0.1 and 4.9 plus or minus 0.1. Which of the following situations will give you the smallest fractional uncertainty? Okay, so let's have a look at all 4 situations. You've got A plus B, A minus B, A times B, and A divided by B. Well, that's a little bit more time consuming. So as usual, we're going to do the following. We're going to look at the rule, we're going to work out the value, and then we'll deal with the uncertainties. So let's see. A plus B, that's our first situation, and the rule is that you must add the absolute uncertainties here. The second situation is also a subtraction, so you must add the absolute uncertainties. The next situation is a multiplication, so this time you must add the fractional uncertainties. Or you could add the percentage, but we don't need that now. The next one we are dividing, so once again we add the fractional uncertainties. Those are our 4 rules for each of these. Next we'll work out our actual values. So that's what we're going to do next. And these are our answers. We get 10 for A plus B, A minus B is 0.2, A times B is 25, and A divided by B is 1.04. So now we've done that, let's work out our uncertainties. For the first 2, it's fairly straightforward. All we're doing is adding the absolute uncertainties. So our absolute uncertainty is 0.1 for A and 0.1 for B. So here we would have plus or minus 0.2 because we're adding. It would also be 0.2 for the next one. Now for the multiplication, we'd have to do a little bit more calculating. Our uncertainty, or our fractional uncertainty, would be equal to the fractional uncertainty in the first one, 0.1 over 5.1 plus 0.1 over 4.9. So let's work that out, which gives you 0.04. Now that is the fractional uncertainty. It is not the uncertainty in U, it's the fractional uncertainty in A times B, right? Which is actually what we're looking for. And interestingly enough, here, because we're dividing, the fractional uncertainty is also 0.04. We're almost there. These 2 are fractional uncertainties, but these 2 are absolute uncertainties. So now we need to work out the absolute uncertainty in A plus B and A minus B. That's simply worked out by dividing the uncertainty 0.2 over 10 in the case of A plus B, which gives us a value of 0.02. 0.02. And we could work out the fractional uncertainty here, but I think you'll find that it's way larger, 0.2 over 0.2, which gives you 1. Okay, so this is definitely the lowest fractional uncertainty, which is A plus B. This question is worked out in exactly the same way as the previous one shown. You're doing a subtraction, so the rule, we look at our rule, we look at our answer, and we work out our uncertainty. Because we're doing a subtraction, the rule is to add the absolute uncertainties. The next is the answer, which is this measurement and this measurement. So you would subtract this value from this value to get 11.5. And then your uncertainty would be equal to 2 times the absolute uncertainty of the measure. What makes it tricky is that our actual measurements here are in half centimeters, can you see? So that is a half centimeter. So each interval is 0.5, so therefore the uncertainty is half that, 0.25, but because you're subtracting this from this, you have to add. So your final uncertainty is plus 5. Okay, so this is fairly straightforward. The lengths of the sides of a rectangular plate are measured, and the diagram shows their uncertainties. You have 50 plus or minus 1 centimeter against 25 plus or minus 1 centimeter. What is the percentage error in the area? Well, first, let's repeat. Rule, answer, uncertainties. So the rule is you are multiplying A times B. So therefore, you need to add the percentage uncertainties. Number 2, what is the actual answer? The answer would be height times the width there. So it would be 25 times 50. So you should get a value of 1,250 centimeters squared. That's your answer. Now for this question, you don't actually need the answer. But if you're in the habit of following these 3 guides, then you would have generated it anyway, and it doesn't matter. Okay, it's good practice to work it out. Don't worry, if you didn't, you're probably just thinking ahead. Why don't we need it? Because the question's asking you to work out the total percentage error. And that percentage uncertainty can be found just by working out 1 over 25 to give you the percentage error in this value, times 100, of course. And then you would add it to the percentage error in this distance, which is 1 over 50 times 100. And that should give you 6%.